2 దశాబ్దాలుగా తెలంగాణ ఆంధ్రప్రదేశ్లో కాంపిటీటివ్ రంగంలో తిరుగులేని సంస్థ
రామయ్య కాంపిటీటివ్ కోచింగ్ సెంటర్.
తెలంగాణ గురుకుల టీచర్స్,
జేఎల్స్, డిఎల్స్,
టీజీటీ, పీజీటీ,
పీఈటీ, పీడీ,
లైబ్రేరియన్స్ కొరకు
స్టేట్ ర్యాంక్స్ తో పాటు వేల సంఖ్యలో అభ్యర్థులను ఉపాధ్యాయులుగా తీర్చిదిద్దిన
డైరెక్టర్ సిరికొండ లక్ష్మీనారాయణ గారి సారథ్యంలో
స్టేట్ ఫేమ్ ఫ్యాకల్టీస్ చే ఆన్లైన్ అండ్ ఆఫ్లైన్ బోధన అందించే ఏకైక సంస్థ
రామయ్య కాంపిటీటివ్ కోచింగ్ సెంటర్, దిల్సుఖ్నగర్, హైదరాబాద్.
100% నూతన సిలబస్ ఆధారంగా ఆఫ్లైన్ అండ్ ఆన్లైన్లలో బోధన.
ఆన్లైన్ కోచింగ్ కొరకు డౌన్లోడ్ చేయండి
రామయ్య కాంపిటీటివ్ కోచింగ్ సెంటర్ మొబైల్ యాప్,
ప్లే స్టోర్ అండ్ యాప్ స్టోర్లలో లభ్యం.
ఆన్లైన్ కోచింగ్ లో అన్ని కోర్సులు తక్కువ ఫీజుతో 1 ఇయర్ వ్యాలిడిటీతో పాటు 1 మంత్, 3 మంత్స్, 6 మంత్స్, 9 మంత్స్ వ్యాలిడిటీ ప్యాకేజీలు అందుబాటులో కలవు.
పూర్తి వివరాలకు సంప్రదించండి
9246208422 88855555202.
Hi, hello everybody. This is your Srinivas. Welcome to Ramaya Competitive Coaching Center online classes. My dear friends, today we are going to discuss about another important, very important and most weightage topic for Gurukula and school assistant mathematics students. Here the important topic is none other than coordinate geometry. Okay. My dear friends, as you know already, of course I have explained to you also in our first class, topic wise weightages. If you check the topic wise weightages for coordinate geometry also, it is the highest weightage topic among all the topics of Gurukula examination. So that is the importance of this topic. And not only for Gurukula, even for school assistant examination also it is a very important and highest weightage. Okay. Once look at the topics which we have to discuss in our coordinate geometry. Okay. So basically coordinate geometry, 2 parts. Everybody knows about this: 2-dimensional geometry and 3-dimensional geometry. So in 2D geometry we discuss only about plane figures which are related to x-axis and y-axis, and in 3D geometry we will discuss about direction cosines, planes, 3D coordinates, and related to x, y and z axis, and points lies in the space. Here the points lies in a plane. Okay, we'll discuss. So the topics in this 2D geometry are: first one is coordinate system. So this is the key topic for the coordinate geometry. When you are thorough in this coordinate system, almost 50% of the remaining syllabus in this coordinate geometry will be easy. Okay, we have to discuss what are coordinate axes and how to represent the coordinates of a point in a plane, and what are quadrants, and what are the signs of coordinates of a point, using the concept distance between 2 points, how to decide the nature of triangle, nature of quadrilateral, etc. things we will discuss here. So their applications only we are going to see in other topics. So then after, second one is a locus, and also very important point, very important points involved in this locus. Why? Because after the completion of a locus you are coming to know that each and every geometrical figure in coordinate geometry is only called analytical geometry. Okay. So each and every geometrical figure in coordinate geometry is nothing but a locus. You are coming to know. You can conclude after the completion of the locus topic. That is also very crucial and important topic. Almost all, it is heart of coordinate geometry. It is heart of coordinate geometry. Okay, this is just introduction. So then after, change of axis is our third topic. In this, two types of transformations, so we can see one is translation of axis and other one is rotation of axis, and we will discuss what is the purpose of having this topic also. Then after, straight lines, which is very important among all these coordinate geometry topics. Okay. In the last Gurukula examination, almost all 8 to 10 questions covered from only this topic, direct or indirect. So then after, pair of straight lines, applications of straight lines, after that circle, okay. After that, system of circle, application of circle we can see in system of circles. Then after, parabola, ellipse, hyperbola, these three topics together called conic section. Conic section. Okay. So these are the topics in two-dimensional geometry. And while coming to 3D geometry, first we have to discuss in this coordinate system as we seen in 2D geometry. Even in 2D geometry also coordinate system is there. So here also we will discuss about coordinate system, x-axis, y-axis, z-axis, and point lies in a space, etc. things we will discuss in this. Then after, related to three-dimensional geometry, another topic, direction cosines and direction ratios. After that, planes. So my dear friends, these are the topics which comes under coordinate system. So coordinate geometry is only called is also called analytical geometry. In your syllabus copy, they will mention coordinate geometry as analytical geometry. Father of analytical geometry, René Descartes. Father of analytical geometry, René Descartes. Okay. So this is about introduction of coordinate geometry, divided into two parts. One is 2D geometry. These are the subtopics we have to cover under 2D geometry, and other part of coordinate geometry is 3D geometry, and only these three are the topics we have to cover under 3D geometry. And it is very important. In last Gurukula examination, almost all 20 to 25 questions covered from coordinate geometry. So that is the importance of this topic. Okay, let's move on to our first topic in coordinate geometry, that is coordinate system. Okay, see, in the coordinate system, first we have to discuss about what are the coordinate axes. My dear friends, all of you know very well that simply x-axis and y-axis are called coordinate axes. Once again, listen my question. I am not asking you the names of coordinate axes. If I ask you the question, what are the names of coordinate axes, you can say x-axis and y-axis. But what I am asking here, coordinate axis. how you will define coordinate axis. Okay. So, coordinate axis are nothing but any two mutually perpendicular lines in a plane. Any two mutually perpendicular lines in a plane considered as coordinate axis. So, what is meant by a plane? According to Euclid, plane is a flat surface which can be extended infinitely in all the directions having ends or lines. Okay. So, plane is a flat surface. Plane shape is not fixed. Somebody will consider plane as a rectangle. Somebody will take plane as a square. Somebody will take a parallelogram, a triangle, etc. But whose edges are line segments and it should be a flat surface. See, this can be considered as a plane. This can be considered as a plane. And another definition for a plane, even this is also a flat surface can be extended infinitely in all the directions whose edges, whose boundaries are line segments. Can you call it as a plane? No. Why? Because another hint to identify a plane, if we consider any 2 points on this surface, another hint to identify the plane, if you consider any 2 points on that surface, line joining those 2 points, completely belongs to the same surface. If the line segment joining those 2 points completely belongs to the same surface, then only it is called a plane. If I consider 2 points here, joining them PQ line segment, it is entirely belongs to the same surface. But such case happens for each and every line segment. Okay. In this case, that is the condition failed. That's why it is a flat surface but not a plane. But it can be a plane. It can be a plane. You consider any 2 points on this surface and join those 2 points, whichever the line segment thus formed, completely belongs to the same surface. Completely belongs to the same surface. So that's why it is called a plane. This is the plane we are going to use for our coordinate geometry. Okay. My dear friends, coordinate axis defined as any two mutually perpendicular lines in a plane considered as coordinate axis. Here you draw any two mutually perpendicular lines. We can draw infinitely many ways to mutually perpendicular lines, but among all those, one of the way, for our convenience, we will draw one of the straight line is vertical and another straight line is horizontal. It is not mandatory, just for our convenience we are drawing. Actually, according to the definition, any two mutually perpendicular lines treated as a plane. See, the point of intersection of coordinate axis is called origin. Origin is always denoted by O. Next, horizontal line in these two coordinate axes is x-axis, denoted by x dash. XO x dash straight line is x-axis. It is called x-axis. This is horizontal. Okay. Next, vertical line in this plane is called y-axis. Horizontal line is x-axis, vertical line is y-axis. Okay. See, point of intersection of coordinate axis is origin, and also observe that coordinate axis always divides the plane into 4 equal parts. Coordinate axis always divides the plane into 4 equal parts. Each part is called a quadrant. Okay. See, quadrant means it is 1/4 part of whole plane, and x-axis itself it is a number line. X-axis itself it is a real line. Means we can see all the real numbers on this line. Here, at the point origin 0, right side of origin on x-axis we can see all positive real numbers, and left to the origin we can see negative real numbers. Above the origin on y-axis we can see positive real numbers. Below the origin on y-axis we can see negative real numbers. Okay. See, this is called a quadrant. This is another quadrant. Always coordinate axis divides the plane into 4 equal parts. Each part is called a quadrant. In this, once again, you think about a quadrant. Actually, the quadrant is nothing but a part of a plane. Bounded by positive x-axis, positive y-axis, and edges of a plane. So, these 4 are the boundaries of first quadrant. A part of a plane bounded by positive x-axis, positive y-axis is called first quadrant. It is denoted by number 1 or Q1. Q1 stands for quadrant 1. Okay. And a part of a plane bounded by negative y-axis and negative x-axis and positive y-axis is called quadrant 2, else it is denoted by 2. Next, negative Q3, this is 3. Positive negative, it is Q4, it is 4th quadrant. Okay. So, this is about coordinate axis. Okay. Next, coordinates. How do we represent coordinates of a point in the coordinate system? So, coordinate system means it is the combination of x-axis, y-axis and a plane. In that coordinate system, how do we represent a point? What are its coordinates? Let's discuss now. Okay. See, this is a plane. In this plane, this is a horizontal line, x-axis, and this is vertical line, y-axis. Okay. Horizontal, vertical. Let P is any point in a plane. Let P any point in a plane means it falls in 9 positions. If I mark the point in a plane without seeing, it can be in 9 positions. Those 9 positions are in first quadrant, in second quadrant, in third quadrant, in fourth quadrant, on positive x-axis, on positive y-axis, on negative y-axis, on negative x-axis, on negative y-axis, and at the origin. These are the 9 relative positions of a point. See, if I consider a point somewhere here in this plane, if I consider a point P in the plane, this is the perpendicular distance. This is the perpendicular distance from the point P to the x-axis, and this is perpendicular distance from the point P to the y-axis. Okay? PM, PN are perpendiculars drawn from P to the x and y axis. O to M distance is small x. O to N distance is small y. As it is a rectangle, its opposite sides are equal. This is y, this is x. In this situation, P point coordinates can be taken as ordered pair x comma y. Ordered pair x comma y. P point coordinates can be taken as ordered pair x comma y. Here x represents the distance of this point from y-axis. Here y represents the distance of the same point from x-axis. Okay? Point coordinates can be taken as px comma y. Okay? How do we obtain x here? Whenever a perpendicular is drawn through the point P to the x-axis, meeting the x-axis at M, O to M distance is x. Whenever a perpendicular is drawn through the point P to y-axis, meeting y-axis at the point capital N, O to N distance is y. Then the point P coordinates taken as ordered pair x comma y. Okay? See, suppose P point coordinates x comma y. Here x is called x coordinate or abscissa of a point P. Here x is called either x coordinate of a point P or abscissa of a point P. Y is called y coordinate or an ordinate of a point P. An ordinate of a point P. Once again, if the coordinates of a point P are x comma y, where x is called x coordinate of that point or abscissa of that point, y is called y coordinate of that point or ordinate of that point. Okay? See, sometimes x is also denoted by p suffix x. P suffix x stands for x coordinate of the point P. Sometimes y is also denoted by p suffix y. P suffix y. Okay? Here x represents perpendicular perpendicular distance of P from the y-axis. Y represents perpendicular distance of P from the x-axis. From the x-axis. This is very important point. Here x represents the perpendicular distance of this point P from y-axis. Y represents this length is y. That's why it is called a perpendicular distance from perpendicular distance of a point P from the x-axis. Don't confuse that. X represents distance from y-axis, y represents distance from x-axis. Okay. Now, look at the origin. How do we write the coordinates of a point origin? Okay. Origin is the point of intersection of x and y axis. In order to construct the coordinates of any point, we have to write the distances of that point from the coordinate axis. What would be the perpendicular distance of the origin from x-axis? If I draw a perpendicular through origin to x-axis, so where it intersects x-axis? At the point O itself. Whenever a perpendicular is drawn through the point P to the x-axis, if it is intersecting in M, O to M distance is considered as its x-coordinate. In the same way, if I draw a perpendicular through the origin to x-axis, where it intersects x-axis? At the point O itself. So, O to O distance is how much? Is 0. Similarly, if I draw a perpendicular through the point O to the y-axis, again it will intersect y-axis at the point O itself. So, that is why O to O distance is 0. Origin coordinates can be taken as 0, 0. Origin coordinates can be taken as 0, 0. Okay. My dear friends, point which lies on x-axis, suppose this is the point Q lying on x-axis. Of course, in particularly it is in negative x-axis. How to write the coordinates of a point Q? Writing the coordinates of a point Q is, this is the procedure. We have to draw two perpendiculars through the point Q to x-axis, Q to y-axis. Q to x-axis, Q to y-axis. While drawing a perpendicular through Q to x-axis, it intersects x-axis at the point Q itself. At the point Q itself. Okay. What is the distance between O to Q? Let it be x1. Okay. Its x-coordinate will be x1. What is the perpendicular drawn through the point Q to y-axis? So, Q to x-axis, that is 0. Q to y-axis, this is the perpendicular. Here to here distance is x1. Q to x-axis distance, Q point to x-axis distance. See, if Q is a point on x-axis, we have to draw two perpendiculars through Q to the x and y axis. If I draw a perpendicular through Q to x-axis, again it will intersect x-axis at Q itself. We have to calculate the distance from origin to Q. Yes, that is x1. Next, we have to draw a perpendicular through Q to y-axis. It will intersect at origin. Origin to origin distance is 0. So, that's why its coordinates can be taken as x1, 0. Similarly, if we consider any point on y-axis, its coordinates can be taken as 0 comma y1. Okay. So finally what I am going to say is, every point in a plane, every point in a plane is of the form an ordered pair, is of the form an ordered pair. In that ordered pair, first one represents x coordinate, or it is also called first coordinate. Second one y coordinate, it is second coordinate, ordinate. This is first coordinate, x coordinate, abscissa. Okay. See, x comma y is an ordered pair. If the point lies at the origin, its coordinates can be taken as 0 comma 0. If the point lies on x-axis, coordinates can be taken as x1 comma 0. Lies on y-axis can be taken as 0 comma y1. So this is the representation of coordinates of point. See, next, signs of coordinates in various quadrants. Suppose this is the coordinate system, this is the coordinate system. As we discussed so far, x and y axis, here it is positive, negative, negative. This is quadrant 1, this is quadrant 2, this is quadrant 3, this is quadrant 4. Each and every point in this plane is of the form an ordered pair. Whichever the point you consider, its coordinates must be ordered pair. Okay. Suppose P is a point, is of the form ordered pair x comma y. If P is in Q1, then if P lies in quadrant 1, then x positive, y positive. Each and every point in the first quadrant are also ordered pair form. Because of first quadrant is formed by positive x-axis, positive y-axis. Okay. In that, x coordinate is positive. X coordinate is nothing but parallel to positive x-axis. Y coordinate is parallel to positive y-axis. That's why x is positive, y is positive. If P lies in Q2, then simple, whenever P lies in first quadrant, x greater than 0, y greater than 0. P lies in second quadrant, x less than 0, y greater than 0. P lies in third quadrant, x less than 0, y less than 0, negative, negative. Fourth quadrant, x positive, y negative. That's why x greater than 0, y less than 0. And however, P lies at the origin, x is equals to 0, y is equals to 0. But if P lies on positive x-axis, so 1, 2, 3, 4 quadrants over. Next, if P lies on positive x-axis, then P lies on positive x-axis, then x greater than 0, y is equals to 0. Number 3, if P lies on negative x-axis, then if it lies on negative x-axis, x is negative, y is 0. X less than 0, y is equals to 0. If P lies on positive y-axis, x is equals to 0, y greater than 0. If P lies on negative y-axis, then negative y-axis means x is equals to 0, y less than 0. If P lies at the origin, x coordinate 0, y coordinate 0. These are the 9 various positions of a point in a plane. Okay. So this is about signs of coordinate axis. Once again recalling you that P point coordinates x comma y, where x is abscissa, so y is ordinate. If it lies in first quadrant, x greater than 0, y greater than 0, because the reason is first quadrant is formed by positive x-axis, positive y-axis. That's why x coordinate positive, y coordinate positive. Next, P lies in a second quadrant. Second quadrant is formed by negative x-axis and a positive y-axis. That's why x less than 0, y greater than 0. If P lies in third quadrant, it is the quadrant formed by negative x-axis, negative y-axis. That's why x less than 0, y less than 0. If P lies in fourth quadrant, because the fourth quadrant is formed by positive x-axis, negative y-axis, x greater than 0, y less than 0. If P lies at the origin, x is equal to 0, y is equal to 0. If P lies on positive x-axis, however, point lies on x-axis whose y coordinate is 0. So that's why here y coordinate 0, x coordinate itself it is positive because it lies on positive x-axis. Next, if P lies on a negative x-axis, x less than 0, y is equal to 0. If P lies on a positive y-axis, x 0, y greater than 0. If P lies on a negative y-axis, x 0, y is less than 0. Okay. Next.